Chapter 3. Yay! Stuff! Okay, so just a couple of quick things. We're going to go through stuff that you really ought to know from math. So let's start out with an XY coordinate here. And pick a point. Well, let's say we have an equation, which is y equals minus 2 plus 1/2 x. Okay? That's our equation. If x is 0, what's y? Well, 0 times a half is 0 minus 2. So if x is 0, this is 0, right? If x is 0, y would be minus 2, and that's a point. We label that point with what's called an ordered pair. Ordered pair. And in the ordered pair, the x always comes first and the y always comes second. So this point is 0 minus 2. Okay? All right? If x is 4, half of 4 is 2, minus 2 plus 2 is 0. So if x is 4, y is 0. That's the point 4, 0. That's the ordered pair. And knowing that this is a straight line, we could then draw that line through those points, and that would be our equation. Is that beautiful? Okay. The trick here is I'm reminding you of these ordered pairs. Now, we also kind of went through one other thing, which we need to make sure that we get. And that one other thing is the domain and the range. Okay? Okie dokie dokie. So if I take an equation, say y equals 10 plus 6x, and I just leave it like that, well, the domain is all the possible values of x, and the range is all the possible values of y. So this equation just laid out like it is, range and domain are infinite. Now, if I say no. The domain of this function, let's say the domain of this function, okay, equals positive integers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. That would mean the range of this, well, the smallest this could be would be 16. So its range would be positive integers greater than or equal to 16. Right? If we put 1 in here, which is the smallest possible integer, we get 16. It's impossible to have a positive integer go in for x and get 10 as the value for y. Okay? So domain and range. Yes? Domain and range. Domain and range. Say y equals 5 minus 2x. Okay? Well, again, if my domain is positive integers, what's my range? Well, if I put 1 in there, 5 minus 2 is 3. If I put 2 in there, it's 1. So the range of this is again going to be positive integers, but greater than or equal to 3. And you could be more specific because it's going to be, right? Sorry, I'm an evil person. The range is not positive integers. I screwed that up. Ignore that. If this is 1, right? 1 gives me 3. 2 for x gives me 1. 3 for x gives me minus 1. 4 for x gives me minus 3. Okay? So really what I have is odd integers, all the odd integers, which are less than or equal to 3. So the domain is the positive integers, 1, 2, 3, 4, 5, 6, 7. The range is going to be 3, 1, minus 1, minus 3, minus 5, minus 7, minus 9. It's going to be all the odd integers that are less than or equal to 3. We got that? Domain and range. The domain is the values of x, and the range be the values of y. Now, you're like, okay, what's the point of that? Well, lots of points of things. In fact, we just points, but anyway, a relation and a function. A relation means that we can specify a relationship between x and y. Now, it could be lots more variables, but just from our point of view, x and y. Okay? A function means we have a mathematical relationship between x and y, where for every x there is a unique y. Now let me explain. Okay? Let's suppose y equals the square root of x. That's my relation. Is that relation a function? For it to be a function, there has to be one y for every x. And that turns out not to be the case here, right? So if x equals 4, what's y? Well, the square root of 4 is either 2 or minus 2. So y equals the square root of x is a relation. There's a definite answer here. I know what y can be, but it's not a function because there are two possible y's. Okay? If, on the other hand, I said y equals x squared, now every time I put a y in there, I get an x, right? So y is all, all real numbers is the domain, right? But the values of y all have to be 0 or positive. I can't square, well, there's imaginary numbers, but if I don't put an imaginary number in there, I get, yes, I have to get a positive. So my domain is all the numbers, all real numbers greater than or equal to 0. That's the range. Okay? Do we see the difference between the function and the relation? The relation here, there's 2 or more possible answers, or there could just be one, right? This is a relation, but it's also a function. This is a relation, but it's not a function because there's not one unique answer. So before we said y equals 10 plus 6x, every x couples with a specific y. That's a function. Okay? It's only a relation if there's more than one possible outcome. And we hate relations. We love functions. We hate relations. Okay? I know you're very excited by that. We hate relations. So, functions. And I'm not making a joke about your aunt and your uncle and all the people you have to spend Thanksgiving with. We don't hate those relations. We just hate mathy relations. Okay, so let's talk about functions. Functions. So, some different kinds of functions. There are what are called constant functions. That's an N. A constant function is something like y equals 2. bow ring. Okay? Then we have what are called polynomial functions. Polynomial functions are this kind of function. That's a squared. All the way out to infinity. Okay? A to the n, x to the n. Now, functions can then be a subset of this. So if I say y equals 10 plus 6x, that's a linear function, draws a straight line, and it's a subset of the polynomial function. Okay? If I say y equals 10 plus 6x plus 32x squared, yes, that's a quadratic function, which is again a subset of the polynomial functions. And there's all sorts of different kinds of these, and we're going to encounter them, right? Because you could have a cube or and they have different shapes. Okay? If I say 10 plus 6x plus 32x squared plus 100x cubed, well, that x squared, if I do x squared, see x squared? If I just do x squared by itself, I get an exponential function. Looks like that. If I do x cubed by itself, it's going to go up and down. Okay? Because plus 100 cubed is 1,000,000. Minus 100 cubed is minus 1,000,000. Okay? So we're going to have all kinds of shapes of functions. And those shapes of functions depends on how far out we go in this polynomial and whether we have even or odd power functions, the exponents. So if an exponent is even, it's always positive. If an exponent is odd, it's going to be both positive and negative. Is that exciting? Okay. I know. So you might get this function here might look like this. The messed up function with all of these things might look like this, but this function's going to look like that. Let's draw that again. So x squared looks like that. Okay, that's 0. X cubed is going to look like this part gets broken off and turned down, right? And so it's going to look like that. And then you can imagine what other things are going to look like. Okay? Some other things about functions. That's an increasing function because it goes up. And this is a, yeah, you got that, decreasing function because it goes down. Now, related to these things is the fabulous word monotonic. Monotonic means the function goes in one direction. So as I've drawn these lines, both of those functions are monotonic. Okay? So what about this? If it goes up and then it flattens out and then it goes up again. Well, it turns out that that's monotonic too. Or if it was going down, because it never goes down. All right? So monotonic means it either goes up without going down or down without going up. Now there's also strictly monotonic, which means it goes up or it goes down but doesn't even pause. So these three are all monotonic, but only the two at the top are strictly monotonic. Do you like that? Yeah, figured you'd like that because it's so beautiful. Okay, some other things. One is what we call extremum or extreme values. And yes, you're going to have to live with my handwriting for 5 weeks here. So let's suppose I have this as my function. Okay? What are the extreme values? Well, extreme values are any place where this line hits a peak or a valley. It hits a high point or a low point. Okay? So, all right, those are all extreme values. But some of them are local. Local means it's extreme in its little area, but it's not extreme for the whole thing. So this point and this point are locals. If this is the entire function, right, and there's nothing else but this function, those 2 points are local extreme points. And these 2 points are global. So this is the global max. This is the global min. This is a local min and a local max. Okay? Is that exciting? So we're going to find all these extreme values. That's one of the important things we're going to do in this class is find extreme values. And part of what we have to know is whether we've found a local or a global. Is that exciting? Okay. We're not as excited as you ought to be, probably. Okay, so here I have a curve. Okay? If I draw 2 points and then connect those 2 points together, that line is called a secant. Is that fun? It's a secant. Now, it can be important because the slope of that secant turns out to be the average slope of the blah, 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 blah. And it's all very exciting.